Algebra 2. Today our learning target is learning how to solve systems of linear equations still containing two variables using the process of elimination and substitution. I can solve a system of linear equations of two variables using elimination and substitution. It is section 3.2 in your textbook. It's called Solving Systems Algebraically. There are two methods we're going to be looking at. Elimination is the first one, and then substitution. The elimination process, the things that you need to remember in order to be successful, is elimination is basically an algebraic method used in solving systems of equations by eliminating, thus its name, or canceling one of the variables. And the only way you can do that is by adding or subtracting the coefficients. So basically, in order to cancel a variable, you want the terms to add up to 0. Both equations must be in standard form. Quick reminder, standard form from Algebra 1 is ax plus by is equal to c. Your goal is to cancel one of the variables by getting a sum of 0. In other words, if you have a 7x and then in the next problem you have a negative 7x, together that makes 0x, and that's what I mean by canceling. You want it to add to 0. All your answers in the elimination process need to be written in ordered pair form, so x comma y. We learned when we were graphing systems that there's actually 3 different types. So sometimes your lines intersect, and when that's the case, you get an ordered pair answer, as I mentioned a second ago. But since we're solving systems by elimination, it's basically a different way to solve the same problems I gave you last week. So instead of having you graph them to find the answer, I'm having you use algebra today to find the solution. So again, if you have an answer, you're going to write it as an XY ordered pair. There are some special cases though. Sometimes when you're working these problems, the x variable will cancel, the y will cancel, and then it'll equal a number. So for example, if you see 0x plus 0y equals 3, that's no solution. And the reason it's no solution is no matter what value you pick for x and for y, anytime you multiply 0 times a number, and then 0 times another number, when you add those values together, it's never going to equal 3, for example. And so there's no solution when 0x plus 0y equals a number. On the other hand, if your variable x cancels in the problem and you get 0x left, the y's cancel, you have 0 y's left, and then the numbers cancel as well, basically everything is 0, then that means there's infinite solutions. And the reason being is no matter what you select for x and y, when you multiply anything by 0, it's going to equal 0. Okay, so our first example for solving by elimination, first thing you want to do again is to make sure the equations are in standard form. So notice that I have an x term, a y term, and a number. Same deal on the second equation. And what you really need to look for is, are they lined up vertically? Are the x's in front, y's second, equal sign third, and then the number? This one's in good shape. I want you to notice that when you look at the coefficient of x, when you add 3 plus 2, it gives you 5. So these do not cancel right now. The y coefficient does cancel because positive 4 minus 4 is 0. And so what you'll do, this is an easy example of this process, is it's already ready for me to solve because the variable y is gone. So the next thing you would do is basically combine your like terms. So what you have left is you have 5 x's, the y's are gone, and then equal positive 12 and a positive 8, you're just going to combine those to get positive 20. Okay, now you have a one equation, you've turned two equations that had two variables into one equation with one variable, which is much easier to solve. Then you're going to divide both sides by 5. And when you do that and finish this problem, your job is to write down the final solution, and that's going to be x is equal to 4. Okay, so I found x is equal to 4. All right, next, since I know that x actually has an answer, I'm going to come over here to the side and record it in my ordered pair. Now what I'm missing is the y variable. I need to know the y value for this problem. So what I'll do is I'll go back and I'll take the value for x, and I get to substitute it into one of these top equations. And it does not matter which one you select. Okay, so I'm going to choose the top one. This is going to be 3x, just copying it back down, plus 4y is equal to 12. If we just found x to be 4, we're going to substitute 4 in x's place. 3 times 4 is 12. Then you're going to solve for y. Drop your 4y down. And you're going to bring this 12 across the equal sign, change its sign. So now you're left with 12 minus 12. Okay, then we have 4y is equal to 0. You'll divide both sides of the equation by 4 to finish it out. And then looking in the next step, I'm going to be left with y. First cancel. Y is equal to, and then 0 divided by 4 is just 0. And so then I'll come back up here and record my answer in an ordered pair form. And so the final solution is 4, 0. And so again, to try to connect it back to what you were just learning in the last section, this problem right here is a system. It has 2 equations with 2 variables. And so when I take each of these, what we did in the last section is we solved for y, we put it in slope-intercept form, and we graphed both equations on the same sheet of graph paper. What this answer is telling me is if I went back and did those steps from the last section, these lines would intersect at the point 4, 0. So this process, called elimination, is an algebraic way to do the same problem without having to graph each line or each equation. And so it's just a different way to find an answer to the same types of problems. Okay, example 2. I have 2x plus 7y equals 4 and 3x plus 5y is equal to -5. And I notice that everything's in standard form. The x's are lined up, the y's are lined up, and I have my numbers as well. What I don't like about this problem is that nothing's canceling for me. 2 plus 3 is not 0. 7 plus 5 is not 0. And so I'm basically going to have to take this problem and figure out a good way to get rid of either the x's or the y's. Okay, a couple different options. Looking at the x terms right now, I have a 2x and a 3x. There is no whole number I can multiply 2 by to make it a 3. I would like this to actually be a -3, and that way it would add to 0 and I could cancel. But 2 times 1 is 2, and 2 times 2 is 4. So we're trying to find a whole number that we can multiply this by to make it be -3, and that's not going to happen. Likewise, we can't make 3 be -2. And so sometimes what happens in these questions is you're going to actually have to multiply like an entire equation, actually both equations, by a number that's going to force the coefficients to be the same number and one have the opposite sign. Okay, so what I'm going to do, let me erase my question number 2 here. Get rid of this so we don't get confused, but this is example 2. If we want to get rid of the x's, we've got to make these two numbers be the same thing. And so a good way to do this is to think of a number that 2 and 3 both divide into, and that would be 6. So if I multiply the top equation by just a 3, that'll make this term 6. But I can't just multiply the x term by 3. I have to treat all terms in an equation the same. So that's why I put parentheses around the entire equation. Now the top number up here will be 6, but now I need this to be a negative 6. So what I'll do is I'll multiply it by negative 2. So when you're looking for, if it's not a problem like number 1 where it cancels easily and you're going to have to figure out what to multiply by, a great way to do that is just to multiply these coefficients together. 2 times 3 is 6, meaning 6 is what you really want the coefficients to be. So then you have to think of a number that you can multiply the entire equation by to force this to be 6 and this to be negative 6. Okay, so the next step is to actually distribute through. And so we're going to change the top equation to 6x plus 21y is equal to 12. When I multiply the second equation by negative 2, it becomes negative 6y minus negative 6x minus 10y is equal to positive 10. Okay, so basically we have changed the way the equations look, but they're still equivalent to the original. And the only reason we did that is to accomplish our goal. We're trying to cancel one of the letters. 6 minus 6 does give me 0, and so that works nicely. So there's 0x left. And when there's 0x, I just usually don't write it down. Okay, in the next term, I have a positive 21 and a negative 10. Okay, 21 minus 10 is going to give me an 11. So I'm going to drop that down underneath the line, 11y equals, and then I notice that the top equation has a positive 12 and the bottom has positive 10. When I combine those, it gives me a 22. And then I'm going to divide through by 11. And the final answer for this, for the y value, it looks like, since we're solving for that first, y is going to be equal to 2. Okay, now that I know I found the y variable, y value for the variable, I know this is also a system where it intersects, and so I'm expecting an ordered pair answer. But this time I actually found the y value first, so I want to make sure that I put it in the right position. So I'm looking for the x right now. Okay, I'm missing x, so what I need to do is I need to go back and take this 2 and pick one of the top 2 equations up here and substitute it in. It does not matter which one you select. I'm going to pick the first one. I'm substituting 2 in place of y because we just found that value. I'm going to end up getting 2x plus 14 is equal to 4. I'm going to transpose the 14, so 2x is equal to 4 minus 14 when the 14 comes across. Now I'm left with 2x is equal to 4 minus 14 is negative 10. I'm going to divide by 2. And it looks like I am left with x is equal to a negative 5. Okay, so I'll come back up here and I'll substitute negative 5 in x's place. And so final solution to this system of equations is the x value is negative 5, the y value is 2. So if I were to graph it, these 2 equations would intersect and be consistent and independent, but the final solution would be negative 5 and 2. Okay, third example. I see a negative 3x plus 5y is equal to 12. A second problem, I have 6x equals 10y minus 21. One thing I noticed right off the bat is that this equation is not in standard form. The y needs to be transposed over in front of the equal sign. Okay, so I'm going to rewrite this one. I got negative 3x plus 5y is equal to 12. The second equation is going to be 6x minus 10y is equal to negative 21. Okay. All right, so next, I can ignore the original problem, and our focus right now is just on this one. I'm going to see if anything cancels nicely for me. I have a negative 3 and a 6, and that unfortunately does not add up to 0. 5 minus 10 also does not add to 0. So I have to figure out a way to make one of these variables cancel. In the last example, I chose to cancel the x's. I think right now I'm going to choose to cancel the y's. Again, you have all kinds of options you can choose. There's more than one way to do all of these problems. So I'm going to look at the 5, and then the bottom is negative 10. And what I would really, really love to happen is if this were a positive 10, then 10 minus 10 would cancel for me. And so now I have to think backwards. If I have a 5 in front of the y, but I want it to be 10, I have to think of what number I can multiply the entire top equation by to force it to be 10. And that value would be a 2. And so underneath, I'm going to rewrite this problem. I'm going to multiply 2 times everything. It's going to be a negative 6x plus 10y is equal to 2 times 12 is 24. I did not change the second equation, so I'm going to recopy it in my notes. And now I'm looking at this equation. Okay, but you'll make sure you leave all your steps on your paper, just kind of skip lines so you can keep it organized, and so that way you don't lose your place. Okay, so here's my new problem. I noticed that I was trying to eliminate the y's, and I did accomplish my goal because 10 minus 10 is 0, and that's good. But when I did that, I now notice the x's cancel as well. Negative 6 plus 6 is also 0, so that's interesting because that usually doesn't always happen. It hasn't happened until right now in our notes. And so when I don't have a variable left, I have to kind of write that down to show the reader that I'm really missing a letter right now. There's no x and there's no y. But I still have to finish the problem because it says I have 24 and then a negative 21 on the bottom. Well, if I subtract 24 minus 21, that gives me a positive 3 back. Okay, so what I'm looking at right now is a 0x plus 0y is equal to 3. I have this statement. And based on your notes from today, we looked at 3 possibilities. Either these systems are going to have one solution, and you'll have to record your order pair, going to have no solution, or infinite solutions. And so now the question is, which one of the special cases is it? Is it a no solution? Is it an infinite solution? How do I know? Okay, you can guess and check. You can pick any x you want and any y you want, and you can substitute it in. 0 times anything plus 0 times another number that you pick is never going to equal 3, ever. Okay, but so because no matter what value you pick for x and y, and I multiply it by 0, it's not going to be 3, meaning that this answer or this problem does not have an answer. It is a no solution question. And again, just to tie it back to things you've already done, if this answer is no solution, that must mean if I were to start back from the beginning of this problem and have you graph these 2 equations on graph paper, when you solve for y equals mx plus b and you found the slope and intercept and you graphed it, they would have had the same slope, different intercepts, and they would have been parallel. Okay, that's what would have happened. And so based on that idea, that's the reason it's no solution. Okay? All right, so that was actually just how can I solve systems of equations using elimination. And then next time we'll look at, or the next part, we have to look at how do we take the same equations and learn a third method to solve these called substitution. Okay, so we have accomplished this one today, and we'll pick up the substitution next time.